Now we've looked at simplifying radical expressions with just numbers and with just variables, and now we're going to look at combinations. So if you haven't seen those other two videos, no idea what I'm talking about, this is going to be crazy. So go look at those first and then come back and take a look at these. So basically now we've talked about how we can say simplify that, and we can simplify this. I've got too many fives. Love that. Okay. So hopefully you remember. You can take this and turn it into this. So it's that times that, which is that times that. Good? And then this one we solved by going 7 divided by 2 is 3 remainder 1. So there were 3, feels like so long ago now, remainder 1. Okay, so it shouldn't be too much of a shock to know that we can do this. And by doing this, we're simply going to separate it all out. So I'm going to go ahead and show all the steps, even though I just did show all the steps. Go on ahead and take care of this one. If I'm showing too many steps and it's freaking you out, don't look. Just go straight to the answer. And now I just want to write things in order. I want to keep the things that are outside the square root sign together, and then the things that are inside the square root sign together. Okay? So that's kind of where we're going to go. And since I feel like I've kind of explained the other things, doing them independently, at this point I'm just going to give you some problems and kind of set you loose, and then I'll come back and check on you. So let me give you some problems. Stop that. Let me give you some problems to look at, and then we'll go from there. Alright, so here's a bunch of problems that you should try to work. Again, I'm not assuming that this is the first time you've ever seen this. You know, I'm assuming that you've seen the reducing the numbers video and reducing the variables video. So you really do need to go watch this first. This is more for practice and honing those skills. So if you haven't already, pause the video, go work these problems, do the best you can. They might take a while because you've never done them before, potentially, and then come back and look and see how we did them. Okay? So now, assuming you've done that, which is perhaps a bad assumption, but we'll pretend that you did. And you should, because it's like good for your education and stuff. So, let's go work these problems. Okay, so this is similar to the one we did in the example. I'm going to look at these and I'm going to say, okay, I'm just going to start by separating them out. Square root of 25, square root of x cubed. This actually isn't a big problem. This is it's actually pretty straightforward. Square root of 25 is 5. 3 divided by 2 is 1, remainder 1. So 1, remainder 1. That's it. Actually pretty quick. Okay. Next one. This one looks more fun. So I'm going to separate all these things out. Cube root of 6 and the cube root of 8. Why the 8? I know what I mean. It's just not what I'm saying. Now, 54. I need a cube. My cubes are 8, 27. That one will do. That one will do. And again, if you're not getting the 27, you know, it's just something that comes with time. It's a horrible thing to say. Just the more of these you do, the better you'll get at recognizing them. Oops, not times. 6 divided by 3 is 2, remainder 0. So 2 with nothing left over. Then I've got 8 divided by 3 is, again, 2, remainder 2, right? 6 plus 2 is 8, yeah. So I've got 2 and a remainder of 2. Alright, so I can break this apart. The cube root of 27 times the cube root of 2, x squared, y squared, cube root of y squared. Cube root of 27 is 3, and then all these are still there. And again, I'm showing every single step, one step at a time. You can probably get these done a little bit faster if you skip steps, but don't skip steps if you don't know what you're doing. It's not going to help. And now I want to reorder these where all the things outside go together and all the things inside go together. Like that. So see, it's not that it's, well, it is kind of hard. I think it's just long and involved and involves a lot of brain power. So I guess that's the opposite of easy. But it's just a case of doing it. And you gotta want it, I guess. That's the best way to describe it, is you gotta want it. Okay. Alright. I'm gonna do this one first, because I'm just thinking that hard. 1, remainder 3. And now for my stupid 81. Okay, so I gotta remember my fourths. 2 to the 4th. 4 times 4 is 16. 9 times 9 is 8. Oh, sweet. Sweet, sweet, sweet. So this is 3. The 4th root of 81 is 3. And then this one is x is 1. Remainder 3. Holy jambalama. I'm just going to write them closer together because it looks weird that way. But that's the answer. So it was actually pretty quick. It just looked scary. No! Yes. Sorry. I want to talk myself out of the right answer. Don't do that. That's a bad idea. Alright. Woo! That was fun. Okay. 2 more, right? 2 more? Alright. Now, don't let this freak you out. There's a couple of ways to do this, but generally what I found is everybody likes doing it the way I don't do it, so I'm going to do it that way. Square root of 50 times the square root of x over 2 times the square root of 2. So I'm going to go with that, and I'm going to say square root of 50. Hopefully you're coming up with 2 times 25. And again, I'm just showing every single step because I'm crazy. So that's going to be square root of 25 times the square root of 2 times the square root of x over 2 times the square root of 2. Now, this is where you can actually cancel something out, which is amazing. The square roots of 2 cancel out because everything's being multiplied by each other. There's no addition signs. There's no subtraction signs. Everything's being multiplied. And so if I have something on the top, it's just like if I had, 3x over, 5x. I can cancel the x's out. It's the same thing. I can cancel out the square roots of 2. Okay. Yay! Square root of 25 is 5. That's left. And that's left. Chunk. So that was kind of tricky, because I never showed you how to do that. But, that's what learning's about. Learning is fun. Alright, last problem. Come here, chunk. Chunk. There we go. Ah! Okay. Sorry, I'm starting to get punchy. Punchy? I don't know where it is. Excited? The 7's out front, and I have no idea why. Arbitrary 7. Cube root of 48. Cube root of x to the 4th. Cube root of x to the 8th. I don't know who sits around making up these problems. Oh, yes, I do. It's me. Cube root of 6. Cube root of y squared. Alrighty. So, there's still lots of 7 out front. 48 cube roots. I think I'm going to go with 8 times 6. It's not right, because my cubes are that. It's not going to be 27, and it's not going to be anything bigger than that. So it's got to be 8. Times 6. Then I can go and I can reduce these little exponent things. 4 divided by 3 is 1, remainder 1. 8 divided by, I changed that x to a y, didn't I? But you thought I was crazy. No, if you've seen enough of these videos, you know that I do that all the time. I do it all the time. 8 divided by 3 is 2, right? Math is hard. 2 remainder 2. Division is hard. Math isn't hard. Division is hard. 2 divided by 3 is 0 remainder 2. So that just means it sticks inside. Okay. So I've got, for the x, I've got 1, remainder 1. For the y, I've got 2, actually remainder 2, which is just a coincidence. And on the bottom, I've still got that cube root of 6. It's starting to look promising, actually. And then this one is just 0 remainder 2, 2 on the inside. Okay, so I'll separate these out again. 7, I don't know what that's, cube root of 8 is 2, and I got the cube root of 6 left over still. I can write the x squared and the y squared. I'll just read like this. Chunk, chunk, jump, 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 jump. Zoop, zoop, doo 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 doo, and that. Like that. Woot! Yay! Okay. Now things cancel out. See, those cancel out, which is amazing. And then these cancel out, which is also amazing, so it means everything's on the bottom. And now I'm just left with on the top. I've got 7 times 2 is 14, x, y squared, cube root of x, and I boxed it in because I'm so excited, and I get a smiley face. Yay! And fireworks. Because I actually solved the problem. And if you didn't get that all on your own the first time, don't worry about it. That's a pretty rough problem. It's just about taking it step by step and doing absolutely everything right. And as long as you can do that, you know, you're good to go. But again, just do lots and lots of practice with these problems. The more practice you do, the better you're going to get.